Good afternoon guys, and welcome back to my channel. Today I would like to discuss with you about special numbers. As you may know, mathematicians are really creative at defining special properties that can be verified just by a small amount of numbers, just so they can call them unique numbers. It's for fun. What about this number, for example? Let's call a number n, and its digits are A, B, C, D, E, and so on. I would like to find number sense such that n is equal to A to the power of A plus B to the power of B plus C to the power of C plus D to the power of D, and so on. This is pretty rare, Number 1 is a small example. Of course, it's dull because 1 to the power of 1 is obviously equal to 1. But I would like to find other numbers with this property. When you raise powers, you must be very careful, as you may know, because you cannot do this operation here. You cannot raise 0 to the power of 0, because it's undefined. It's just a mathematical issue. So numbers like 305, for example, cannot be written as 3 to the power of 3 plus 0 to the power of 0 plus 5 to the power of 5. It's just a complete nonsense. So I wrote in Matlab a code that allows me to find other numbers like n by skipping every other number with zeros. Let's head to Matlab then. This function is called find 3435. This is not a casual name, as you will see here later. I initialize an empty vector h, which is going to be my output, then a for cycle for I that goes from the floor of my minimum to the ceiling of my maximum, where minimum and maximum are variables that I decide, so I decide where to find numbers from such number to another number. I decide. Then I convert my current number, the current number I'm examining, to a vector through this function that I wrote myself here, and I will explain it later. So basically I'm doing this small little trick. For example, 205 or better 215 is going to be written like that. A vector which every component is the digit of the number itself, resemble the number itself. And this is going to help a lot, because now we can treat a number as a vector. Then I define an empty G vector here, or better, a G support vector made by ones. Then this is the important part. If is equal n non-zeros of v transposed and v, then I will continue. This means that if my vector without any zeros is equal to my original vector, then I can proceed. This means, for example, here my original vector is 215, and by applying the command non-zeros I will squeeze out any zeros from that vector, but there aren't any, but instead numbers like this are written 506, and non-zeros will transform this vector into 5 and 6. But that is not equal to my original number, so I cannot proceed. If this is true, then I will initialize another for cycle here for n that goes from 1 to the length of my vector. Then my G support vector will be filled in with the powers of my original vector's digit. So I'm basically saving in a support vector this small trick here. But I still have to sum this thing. Then if the sum of every component of G is equal to my current number, the number I'm examining right now, then I will push in my output vector this number. and will display a message. Oh, you found one. Trovato. Let's try this out. From numbers which go from 2, because 1 is a bad choice, as I said before, from 2 to 1000, for example. Here it also displays the elapsed time, and this is granted by tick and tock written right here. Okay, this is the only number that they found, and mathematicians are currently searching for other numbers with this property, because apparently this is the only one. You can try this out and find for even a billionth of number, but be careful with that, because as you can see here, as you increase the interval of research, as you can scope numbers from 0 to 10 to the 7, the number of seconds that will take are going to increase wildly. So to search a billionth of number, you will like to take like 12 hours or so. So be careful with this algorithm, it's not perfect. Let's try another one. In a similar way, I can define another algorithm that can find numbers such that n is equal to a factorial plus b factorial plus c factorial, as I said here, but using factorials instead. This is a little bit more complicated, but the function itself is almost identical. The only thing that changes here is factorial instead of the raising powers. Let's try this out. Okay, I will post everything in the description, so don't worry. Let's try to find these particular numbers from 1. Of course, 1 factorial is equal to 1 to 10,000. This is going to take some seconds here, 13 seconds. The numbers are 1, because 1 factorial is 1, 2 factorial is 2, 1 factorial plus 4 factorial plus 5 factorial does this, is equal to this, and this little guy. Of course, you can do 0 factorial, which is equal to 1. There is no limitation here. The very last function I would like to show you today is the narcissistic numbers. Narcissistic numbers are numbers n such that a raised to the power of m plus b raised to the power of m plus c raised to the power of m is equal to n, where m is the number of digits of n itself. So for example, if n is a 3-digit number, a to the power of 3 plus b to the power of 3 plus c to the power of 3 must be equal to n. And the function is made in a similar way, this time by using length of v, which gives me the number of digits. Let's try this out. From 1 to 1000. These are the numbers. This is pretty interesting because there are twins here. The NumVectConvert function is made such that I can divide at each step the number by 10, and you will figure it out. It's pretty easy if you get it. So thank you for liking, commenting and subscribing. I have no minutes left. I will post everything in the description, and please tell me if this format, if you like this format. See you next video, guys.